Okay, good morning, everyone. Happy Sunday. So, today I'm going to treat a wonderful topic on refraction of light in a triangular prism. Let's do the analysis. So, here we have physics. The topic is what the refraction of light in a triangular prism. This is what I'm going to have today. Now, let us draw the prism itself. See the prism here. You can see the shape of the prism is what? Triangle. Then the name of the prism is what? A, B, and C. Now in this prism, we are using a triangular prism that all their sides are equal. So therefore, the prism is what? Equilateral triangle. So this side and this side and this side are equal. And one thing about the equilateral triangle is what? All angles are what? Equal. So this angle here is equal to this angle here and also equal to this angle here. And the angle of what? Equilateral is what? 60, 60, 60. So in that case, we can say that what? This angle, which is what? 60, is what? The angle of what? The prism. Okay, let me just keep it here. The angle of what? The prism. So the angle of what? The prism A, we use A to represent it. A is equal to what? 60 degree. Always have it in your mind. Now, this one here is what? A. This is A and this is A. Now, if light is coming from this point, I on the torch here, direct it towards this what? Glass. The topic will appear as water refraction because the light is coming from this region to this region. From this region, it will move out of the other region, or it can also come here and even move this side. So there are two directions of the light here. Either the light comes here and come out from this side, or the light comes here and come out of this side. All these things are depending on the what? The angle of what? Incidence. If the angle of what? Incidence is what? Small, the light will come here. If the angle of what? Incidence are what? From 30 and above or 25 and above, we are meant to see the light coming out from the side of what? AC instead of what? BC. So, but the one I want to treat today is what? Not the small angle of what? Incidence. When the angle of incidence is very small. The one I want to teach now is what? The one that will come out from this side, which is what? A big angle of what? Incidence. Maybe from 25, 30, 35, and so on. But the one of what? 5, 10, 15, 20, which will come out from this side now, is not what I'm treating today. Then in that case, if light is coming from here to here, what will happen? On getting to this point, instead of this light to travel straight, as we said, what will happen? It will come here and what? Bend. See the bending effect. Remember, at any interface of what? Any interface, there is always what? A normal. At a point, the light touches the what? Interface. So this angle here is the angle of what? Incidence. Why the light that comes to this point deviated, refracted with an angle which we call what? R1. You can see, angle of refraction is the angle measured from the what? The refracted ray, which is this, to the what? Normal. Now, in that case, what can I say? Getting to this particular point again, what are we going to see? A normal again. Are we there? A normal. This light will get to this interface, moving from one medium to another medium, it will bend. But there is one point I want to make here. This region is what? Air. This one is what? Glass. And this side is what? Air, outside. When light, if you look at air and glass, glass is always denser than air. So when light is moving from less dense medium to denser medium, the refraction occurs as if the light is refracted, as if that refraction is coming towards the normal. You can see it's not moving away from this normal, it's bending towards the normal. So when the light is now coming from dense to less dense, the refraction moves away from the normal. So instead of drawing this thing like this or this way, I am going to draw it like this, meaning that what is moving away from the normal. So this angle is called what? Emergent angle. Remember, here is the what? Incidence. This one is what? The refracted. And this one is what? The emergent. Now, if you look at the analysis, experimentally now, when two normals intercept, you can see where they intercept in this prism. This angle is measured. And when you measure the angle, we are seeing the angle to be what? 60 degree. So what is this 60 degree? The angle of the prism, which is what? A. Because I represent the angle of what? The prism with what? A. Now, you can also see that what? This angle here, I will call it R2. This R2 is what? When you cover this side, and we assume that the light is coming from here, hitting this point, it will refract. Meaning that what? This one now is the angle of what? Incidence to this what? Emergent. The angle that the light is what? Moving in that what? Prism, trying to what? Refract to the other what? Medium. Now, in that case, my drawing is what? About to be what? Complete. So you can see the light that has deviated, we can also measure the deviation of what? The angle here. So let me call here, this is the deviation. The light that's supposed to move here, you can see the direction here, but look at what? The deviation. So here is what? The deviation, D2. And here is what? The deviation, D1. You can see this light is supposed to travel this way, but has been what? Deviated. So from here, let us do a little analysis. Let us do a little analysis. What is that analysis? The analysis says, according to Snell, according to what is Snell, according to the Snell's law, air to glass is what? Sine of I over sine of what? R. So this over 1, when you cross multiply, we are going to have air to what? Glass, sine of what? R is equal to sine of what? I. So if I divide here by air to what? Glass, and I divide here by air to what? Glass, this cancel this. We have sine of what? R to be equal to sine of I over what? Air to what? Glass. So R is equal to sine inverse of what? Sine of what? I over what? Air to what? Glass. So from this formula, which we have proven before in the other days, I can say, so that we can see it very well, our R here is equal to sine inverse of what? Sine of I over what? Air to what? Glass. This becomes formula 1, and this is what? Equation 2. So meaning that what? Once this angle of incidence is given, you can get this refracted what? Angle. So the refracted angle we tag it as what? R1, R1. So another analysis we need to know about this is what? Looking at this, I can see something like this from this triangle. There is something like this from the triangle. Here is represented as R1. Here is what? R2. And here is what? A. Remember we said, according to one of the properties of what? Triangle, that one exterior angle is equal to the sum of what? The two opposite interior angles. So meaning that A we have there is equal to R1 plus what? R2. This becomes what? Formula number 3. Very important formula. Now, in this case again, there is another thing I'm seeing there. What is that thing? Looking at this formula, this particular one here, I am seeing a triangle this way, triangle like this. Here is D1 and here is what? D2. So this angle outside here, this angle here is what? The total D, this plus this. So therefore I can say that from this triangle, there is D here. The D is equal to what? D1 plus what? D2, which will give us equation 4, the total D. Now, but if you watch very well again, you see that this angle here is vertically opposite to this angle. Why? Because we have this and we also have this. So you can see this angle that form between this line and this line is what? I, R1 plus what? R2. So therefore I can say that I is equal to what? I is equal to what? R1 plus what? D1. In that case, to get D1 here, it will be what? I minus what? R1. So I have seen this D1. Coming to the other side, we can see this and this. So E is equal to what? D2 plus what? R2. R2 and D2. So D2 from here now is equal to what? E minus what? R2. So these two formulas are very, very important because we say that D is equal to D1 plus what? D2. And we have found this D1. So the deviation is now equal to D1 is what? D1 is equal to what? I minus R1 plus D2 is equal to E minus what? R2. Now, you see this equation, very, very important equation. But there is a condition here. What is the condition? For this deviation, for the deviation to be minimum, that is what? dm. For this deviation to be what? Minimum, see what happens. For the deviation to be what? Minimum, we are going to have dm will be equal to what? D1 plus what? Sorry. dm is equal to what? I minus what? R1 plus what? E minus what? R2. So for this deviation to be minimum, for dm to be minimum, I is equal to what? E. The angle of incidence is equal to the angle of what? Emergent. And the R1 is equal to what? R2. Meaning that the angle of incidence we have here will be equal to the angle of emergent. And the R1 we have here will be equal to R2. That is the condition for the minimum deviation. So since we are talking about the minimum deviation, our dm is equal to I minus what? R1 plus E is the same thing as what? I. So we are going to put I here minus R1. R2 is also the same thing as what? R1. Now, I can say that what? Our dm is equal to I plus I is what? 2I. And minus R1 minus R1 will give us what? Minus what? 2R1. Now, this equation here can also be modified from, you can see from equation 3. From equation 3, where we have A is equal to what? R1 plus what? R2. But we say that R1 is equal to what? R2. So what am I going to say? Our A here is equal to, angle of the prism is equal to what? R1 plus what? R2 is the same thing as what? R1. So A is equal to R1 plus R1 is what? 2R1. So meaning that any place I see this 2R1, I will also call it what? A. This 2R1 is equal to what? A. So I will now come here and conclude that what? Minimum deviation is equal to 2I minus this one, which is 2R1. 2R1 can be represented with what? A. Now let us get the angle of what? Incidence. What is the angle of incidence? dm, when this crossover, we are going to have plus what? A. Are we there? So, in fact, just for me not to, anyway, dm plus what? A is equal to what? 2I. I will divide here by 2 and by what? 2. This cancel this. I becomes what? dm plus what? A over what? We have 2. So this is the angle of what? Incidence. When deviation, minimum deviation and what? When the minimum deviation is what? Given. Meaning that what? With the help of minimum deviation, we get the angle of what? Incidence. Because your A is always what? 60 degree, which is the angle of the prism. So if the minimum deviation is what? 34 point something or 34, you put that at 4 here plus your 60 divided by 2, you can get your incidence what? Angle. So this particular equation is also important. Now, from here, from what we have as what? A equal to what? 2R1. From this equation, if you divide here by what? 2 and divide here by 2, this cancel this, your R1 is equal to what? A over what? 2. This equation is also important. Then, let's remember the Snell's recall that what? The Snell's law say that what? Air to glass, refractive index is equal to what? Sine of incidence over what? Sine of what? Refraction. Then, incidence goes with what? R1, refraction. So air to what? Glass is equal to sine of our I here is now seen as what? dm plus what? A over what? 2. All over what? Sine of your R1 is equal to what? A over 2. So this becomes the refractive index of a triangular what? Prism. In this thing, if you want to find the refractive index, they must give you the what? The angle of what? Minimum deviation. Once you know the minimum deviation, put it here plus this divided by 2. Press sign of it, you get what? The value here, and 60 divided by 2 will give you what? Sine of it will give you this value. Divide out, you are going to get the angle of what? Deviation. Sorry, the refractive index of what? The prism. As you are watching, Kosi the Great is here to give you the analysis of what? Every particular topic. Follow up, share, comment, and invite others to the page to learn with you. Thank you and God bless you. Love you all.